All right, welcome back. Here we are at part 2, solving systems using elimination. You'll find in your book this is section 7-4. Solving systems. We're looking for that place where the two lines cross. They may cross at one point, they may cross at no points, and they may cross in all points. We'll get into that a little deeper later. Well, why is this in two parts? Because you're going to get problems on this assignment where it's not quite so easy to just add up the two equations. Here's the first one, and here's the other. Now, if you recall, we're putting these in, if they come to me in standard form, I'm going to stack them up by the variables and the numbers. AX plus BY equals C. And if you recall from the last video, we added up these two equations to get one of the variables to eliminate. Well, if I add these two equations, I'll get 8x and 6y, and that's not getting any of the variables to go out. So adding these up now doesn't make any sense. I'm going to have to change one or both of these equations so that I can get them to add up to 0x or 0y. Now, as you study this, which of those looks like it'd be easier to do? To get, in other words, to get maybe 15x and a negative 15x, or 4y and a negative 4y. Well, it sure looks easier that we could get y to go out if we multiply this lower equation by not -1, but multiply it by a -2. So the only thing we're doing now is we're changing more than just the sign, we're changing the numbers too. And -2 times 2 is going to give me -4y. Well, that's opposite of 4y, so when I add those up, that will go out. Now I'm going to have to move this one down here, and I'm going to do that now so you can see what we're doing here. Just move that one down to the bottom. Now if we multiply this 5x times -2, I get -10x. And -2 times -4 is a positive 8. So the two equations we're looking at now are these two. Okay? And if we add them up, you can see that y is going to be eliminated. Once again, we multiplied one of the equations by -2 in this lower one so that these two would be opposites of each other. -4y, positive 4y. So now when I add these up, -10x and 3x is a -7x, the y's go out, and this is 14. Now we can divide both sides by 7 and solve for x because we only have one variable here. So x is equal to a -2. So the ordered pair we're looking for, the xy pair, x is a -2, so I'll put it here. And then I have to take this number and stick it back in one of these equations. Now I can stick it in any of them. I'm just going to pick one of them. Let's pick this one here. Okay, 3 times -2 plus 4 times y equals 6. By the way, how did I pick that? I just picked it because the numbers were simple and small. Okay, -6 plus 4y equals 6. Adding 6 to both sides, we end up with 4y equals 12. I'm out of room down here at the bottom, but that's dividing both sides by 4. I get y is equal to 3. Okay, y is 3. I divided both sides by 4 there. So my ordered pair then is going to be x is -2, but y is 3. So to verify that this is really the right answer, we're going to check this just like we did in the last assignment. And I'm going to check it in the other equation. So I'm going to check this in this equation. It's always a good idea to check it in the other equation. So 5 times -2 is a -10. 2 times 3 is 6. Minus equals a -4. Is that true? Is -10 plus 6 equal to a -4? Yes, that works. So that verifies that that is in fact the right ordered pair. Okay? Takes a little more room here because I had to move this second equation down. I wanted them stacked up right above each other so that it was easier to add. Let's take on another one. All right, here's another equation, and it's written in standard form. Both of them are stacked up. If I add these two equations up now, I get 5x and 1y, and that doesn't get rid of either variable. Well, so now I look at it and go, which equation can I multiply by something so that I have a common multiple? Okay, they have to be a common multiple. We call this the least common multiple, just like finding a denominator for fractions. Well, if I multiply this by something, I'll never get 3. If I multiply this times something, I'll never get 2. If I multiply this by something, I'll never get 4, and vice versa. So it appears to me I'm going to have to multiply both these equations by something different. And I can choose to try to get 6 here and negative 6, or I can choose to try to get 12 here and a negative 12, the least common multiple. Now, I usually try to pick the situation where the numbers are going to be smaller. So I think I'm going to choose to try to make this 6 and negative 6 here. So watch how we do this. How about if I multiply this one times a negative 3, I'll get negative 6, negative 3. I'll get a negative 6. And if I multiply this one up here times a positive 2, I'll get a positive 6. That'll work. So let's do this one first at the bottom, okay? Multiplying by a negative 3 times a negative 3. Well, 2 times a negative 3 is a negative 6x. Negative 3 times negative 3 is a positive 9y. And I have to multiply this number too. Don't forget that. That's negative 18. So I multiplied the lower equation by negative 3. And now I'm going to multiply the top equation by a positive 2. I'm going to put my arrows here so you can see what I'm doing. I'm multiplying this by a positive 2. 3 times a positive 2 is 6. 4 times a positive 2 is 8. And 2 times a negative 25 is a negative 50. Okay, as you can see, our goal was to try to get a variable where we have opposites, in this case a negative 6 and a positive 6. Could I have done something with the other? Sure, I could have gotten 12 and negative 12, but I picked this because the numbers were smaller. So now they're right next to each other. I'm just looking at these two equations now, and I'm going to add them up. And the x term is going to go out. That's eliminating x. So this is 0x or 0. This is 17y. And this is a negative 68. Okay? I have to do a little bit of side arithmetic here. If I divide both sides by 17, it turns out it does go in there exactly a negative 4 times. Okay? So I see that my ordered pair is going to be something negative 4, xy pair. All right? So now I'm going to take this and I'm going to stick it back into one of these equations. Which equation looks like it's going to be the easiest to stick it back into? Well, probably I could put it in all four of these, any one. I think I'm going to take this one because it's got smaller numbers. So here we go, 2 times x, which we don't know, minus 3 times the negative 4, which is y, equals 6. And we get 2x plus 12 equals 6, subtracting 12. We get 2x equals a negative 6. I'm out of room here again, so dividing both sides by 2, I get x equals a negative 3. X equals a negative 3. So x is a negative 3. I'll move it right up here. Now, I want to check to see if this is, in fact, the right ordered pair. But I don't want to check it back in the same equation, just because I'm going to double check myself by doing it in a different equation. So I'm going to pick a different equation. So I'm going to pick this one. 3 times a negative 3 for x, plus 4 times a negative 4 for y. Is that equal to negative 25? This is my check now. Negative 9 minus 16, that's equal to a negative 25. We'll add those together. Yep, we get negative 25. So this is a check. It does work. That is the right one. So what you see that when we do these equations is that you may have to multiply both equations by something different to get the variable, one of the variables to go out. Let's look into something else here. All right, let's take a look at this one here. I've got a problem up here with fractions in it. And not always is it going to be quite this easy when there's fractions. This one's a little easier. But not only do I need to get the variables opposites, either I got a negative some x and a positive the same x, or I got to get y's to be opposites. Now, I think I'm going to choose to get y to be opposites. And if I multiply both of these fractions, both of these equations by something different, I can also get rid of the fraction at the same time, and that can be real beneficial. What if I multiply this top one by 2? That'll give me 1y here. That's good. Actually, a negative 1y. Negative 1y. And if I multiply this bottom one by 4, that'll give me a positive 1y here. So that's what I'm going to do. I'm going to go ahead and let's do the bottom one first here. 4 times this is 20x, plus 4 times a quarter is 1y, and 4 times 8 is 32. Let's multiply the top one here by 2. That gives me 6x. 2 times a negative half is a negative 1y equals 20. Now these two equations, not only do we have equations that I can add together to get an elimination, but also I got rid of the variables, which makes our problem even easier. So let's add these up. 20 and 6 is 26x. These are going to go out, and this is 62. Oh, excuse me, 52. 52. Okay. I think 26 goes into 52. Yes, it does. 26 goes into 52 exactly 2 times. So my ordered pair is going to be 2 something. Now, you can see that I could take that number and stick it back in one of these with fractions. I could stick it into any one of these. But, you know, it turns out it might be the easiest thing is to stick it into one of these at the bottom. I think I'm going to stick it into this one. The numbers are smaller. And they're also, there's no fractions. So let's stick it in there. 6 times 2 minus 1y equals 40. Don't forget you got to multiply every term. Oops, this should be a 2 here. 2y. 6, I'm sorry, it's still y. That didn't change. Okay. 6 times 2 is x minus 1y equals 40. Every term had to get multiplied. I get 12 minus y equals 40. I'm running out of room here. So I got subtracting 12 from both sides. I get negative 1, move this up here now, negative 1y equals 28. Is that right? Oh, I'm not supposed to be multiplying here. I've lost my mind here for a minute. This is supposed to be a 20 still. Lost my mind. I wasn't multiplying by 2. I was simply plugging the 2 in here. So 6 times 2 minus y equals 20. All right, some of you probably saw that and go, what, he's losing his mind. Yeah, okay. So this is 20. And I end up with subtracting 12 from both sides. And I end up with negative y equals 8, or y equals a negative 8. So there you go. You've got an ordered pair where 2 is x and y is a negative 8. Now, I'm not going to go ahead and check this one, but I would check it back in the other equation. In fact, I'll do it in my head here. Let's check it into this one. Let's use this as our check equation. 40 minus 8, negative 8, is 32. That works. So I can check my problems back in the original. All right, let's see where we're going from here. All right, let's review something that we talked about a couple of weeks ago, a couple of sessions ago. And one of the things you're going to notice on the homework is it's going to ask you which technique to use, either substitution or elimination. Well, there's a definite advantage to one over the other depending on the kind of problem you have. Substitution works really best when there's a variable alone or almost alone. And elimination works best when things are in standard form. So if you look at this problem above here, I've got two equations, and this is not in standard form, plus the variable is alone here. So here's a problem where I would choose to use the substitution method rather than elimination, because I'd have to get this in standard form first, and it's just easier to use the substitution method when the variable's already alone. All right, now take a look at this next problem I've snapped up here. The question is which method would be better? Well, x is almost alone here, but if you notice, these are both in standard form. So I would just take this equation and stick it underneath here and go ahead and solve it this way. And when I add these two together, y turns out to drop out. So the better method here would have been the elimination method. So when you're given the option of which method you want to use, bear that in mind, that substitution works great when there's a variable alone or almost alone, and elimination works best when things are in standard form or easy to get into standard form. All right, let's look at your homework for tonight. All right, so here's your homework for tonight. This is the lesson 7-4 in the back of your book. Do 1 through 15. That comes to the conclusion here of working with lines. In the next assignment, we're going to talk about finding the solution of solving a system of inequalities rather than equations. So enjoy that. I'll see you next time.